to see how things have been moving on, and things have moved on. Although I'm happy to say that the cameras that I employed up till about 4 or 5 years ago, they are still for sale and actually still quite current in terms of what the capability is, and I'll show you those, of course, later. So today's episode, well, one thing that I also need to say, go back, is Pete said in the introduction that I'm going to talk about using webcams, but that is that. Yes, I did use webcams, but webcams do have a place in astrophotography, or in video astronomy, if you want to say it less posh. But I've since moved on to use, in fact, modified surveillance cameras, especially, of course, nighttime surveillance cameras, which are actually available at remarkably low prices. And because they are purposely made to be used in low light conditions, they are absolutely superb for astronomical use. But okay, what I'm going to talk about today in the next half hour or so, half hour, 40 minutes max, is why I chose to use video cameras instead of you know, your more conventional CCD cameras. I will tell a little bit about the equipment. I will not tell too much about the history of it all. I'm going to concentrate really of what I've used and what I'm using. Some other things to consider besides the equipment, obviously. I'll try and give you some practical observing tips as well. And of course, plenty of examples. More than 2/3 of my presentation will be showing you some of the results that I've had with using video cameras with my telescopes. And then, of course, this wouldn't be a good how-to presentation if I didn't also tell you a little bit about how to perhaps get started. Now, I believe that Eric, I can see him there. He is also one of our attendees. I actually emailed him early to ask him to perhaps also butt in later on when we have a wee discussion at the end, because he's got also a lot of experience. We did quite a bit of this kind of stuff quite early on. And we shared a lot of ideas, but they have also moved quite a bit in the Hans Astronomical Society using cameras on the telescope. So hopefully he can also give us some additional guidance, or if I don't know the answer to some of the questions that you have, then I'm quite happy to or hope that Eric has offered to help me there. So thank you, Eric, for doing that. So why I chose to use video cameras? Well, for starters, I like a challenge. People that know me know that. I like to do something new, and I also like to do more with less. If I can scrounge a free or second-hand little camera that I can modify to work on a smallish telescope with minimum of kit, then I'm happy, and I will be busy for hours with that. I also like the idea of observing in real time. I like to spend time at the scope. My work involves a lot of computing. The last thing I want to do is spend, you know, all the time behind the computer doing all sorts of stuff with imaging and so on. So I like the idea of using the camera on the scope and see actually on the screen what I can see on the scope. I also wanted to use the cameras to see if I could see much more fainter objects in the same scope, and that is really quite amazing. I have observed 17.8 magnitude stars in 102 millimeter refractor from Culloden. The limiting visual magnitude of a similar scope, or of that scope, is actually 12.4 at very good seeing. So you can see, you can get a huge amount more, you can see a huge amount more stars in using a video camera than just your eye. Another great thing, you can record transient events such as occultations, and I've got a little video that I can show you where an occultation takes place. It's fairly quick to set up. It's actually not much hassle. It's just basically sticking the camera on, plugging it in a power source and plugging it into your laptop, and off you go. I find it also much more comfortable observing. I can observe with both eyes. I don't need to dark adapt. I can sit down looking at the screen of my computer. I've got my go-to panel in one hand, and you know, I can just steer it to what I want to see, and I see it. And okay, if you don't have a camera with remote control, and there are cameras with remote control, then you need to now and again go to the camera to maybe change a setting or so. But that's it. It's very, very good fun. You can share the view, of course. You know, if you've got a group of people that can all look at the screen, or you can even go even further and just connect to the internet and share it perhaps via a YouTube channel. I've also found that, you know, especially when I started this hobby, that the video cameras, those that were converted for the purpose of astronomy, are a lot cheaper than conventional CCD cameras. I think that is in a sense still the case, although more about that later, because there are now a few cameras for sale that are very, very affordable. But of course, you know, I like the video, the immediacy of video a lot. It could be a possible intermediate step to higher end astrophotography if you wish. I still don't like the idea of spending lots of time behind a computer stacking images, and so I do some of that. But to be fair, I'm not looking for Hubble quality artwork. I like my images to be informative, to be useful. I like to see things, and you will see that in the images that I've produced, that I try to actually eke out as much of the detail as I can, not for aesthetic purposes, but for what I want to see in them. So what have I used then? Well, I don't know if anybody remembers this one. Came out in 1998. That is the Logitech QuickCam Express, and you can still find loads and loads of stuff online about that. That camera was one of the first cameras that was used in large quantities by DIYers to stick them on the telescope. It was not too expensive. You could remove the lens very easily. You could get one of those 35 millimeter film canisters, chop the bottom off, fit it precisely in your eyepiece holder, glue that on the front end, and there you go. You have a camera. Unfortunately, it wasn't really any use with deep space, although at later stages people hacked the software, and there's even people that stuck Peltier elements to them to cool them. And some people were able to do deep space stuff with it, but I never went that far. I just did planetary stuff, and I'll show you an example of a planetary video that I took with this camera. But nowadays, what I use is I still use this camera, this telescope a lot. It's a short tube f5 102 millimeter refractor. It's still made, but it looks different, and it's now called Skywatcher. Still on the same mount. I actually use it on the EQ1 mount. A lot of people say, oh, it's all rubbish. It isn't. It's wonderful. It's nice and light, very easy to take with you. And I've done some serious video astronomy with this telescope. But once I got the bug, I invested in this beast here, the HEQ5 SynScan mount. And in fact, actually buying a telescope with it was an afterthought. At the time, this was 900 quid. The scope was 200. But my goodness, what a lovely mount that is. It is so sturdy. And this is a 6-inch f5 scope. So 750 millimeter focal length. That goes on there, and it's just absolutely bomb-proof. Amazing results with that scope. In fact, actually, you know, I don't think I'll ever sell it again, although I am eyeing up a slightly bigger brother of this one. Certainly the mount can handle it. And then in terms of camera, these two cameras I have used a lot. I'm eyeing up a new camera at the moment, and I'll show you which one. And this is a composite video camera. So it is in fact indeed a surveillance camera, and I don't know if you can swap to the screen. I mean, I can stop sharing and show it on the screen, but I'll do that actually for a minute so you can see. So this is the Mintron. It's quite small, but it is very solid. It's quite heavy, in fact, and it is supposed to be a surveillance camera, but the model gives it away. I don't know if it zooms in. Yeah, so it is the model PD2285C. Now that PD in front of it actually means Phil Dyer, and it's a chap in England who had the software changed inside this in order to make it more suitable for Astro video, and you access all the software from this this little panel in the back. 12 volt goes in here, and that is composite video out. Similar is this one. This one is, by the way, black and white, so it's monochrome. This one is color. Similar idea. Both have exactly the same chip in them, but this is the color version, and this is the mono version. And it's the same idea, completely the same. This one doesn't have remote control. We were also given a camera by Phil Dyer that went to the Haas Observatory, and that one does have, I'm holding it upside down, and that one does actually have remote control. So that's the kit. I don't use the lenses on them. In fact, I have a little adapter. So here is a little adapter that screws in the front, and you get it with the kit. It's a nice metal adapter that fits standard surveillance cameras, and that goes in the eyepiece, and that is how you fit it. I also have a few other bits and pieces that I can show you. I have got, and that is quite useful. I've got this little field flattener. This, focal reducer. This reduces the focus, the focal length of the telescope by 2. So instead of having, say, 500 millimeter in my refractor, I get 250 millimeter, and that is quite important with these cameras, and I'll tell you that in a second. And I have a Barlow lens in case I want to increase it, and it is actually the Barlow lens I use to put the focal reducer on, because I unscrew the Barlow lens here, I screw the focal reducer in there, and that allows me then to put the camera in here. And I also use this little tube itself on its own without the Barlow lens, because I don't want to use the star diagonal. So I take the star diagonal off my refractor, for example, and I use this as a little extension tube, because you need that, otherwise you won't get the focus. In the past, I've also made my own cameras. This is a camera I made. It's actually got a video camera inside, and I got the teleconverter for so that I could put lenses on it, specifically Pentax K. You can see the little sensor in there. But the problem with these webcams is that there is no adjustable software. It's just composite out. You cannot do anything other than change the gain. But with these cameras, especially this Mintron and the Hooveron, you can do an awful lot of adjustment. Indeed. So let me go back to my presentation. This one. There we go. So moving on quickly. So things to consider. Now, as with always, aperture, very important. But in the case of video astronomy, also focal length. What you will find is that if you do not use an eyepiece, you don't get the magnification the eyepiece produces. So if you stick a camera on a telescope, the first thing that you will notice is that especially planets and other things are very, very small. Hence the fact that that you need to, for instance, quite often use something like a Barlow lens to get a little bit more magnification. It's also not so much about the pixels. Of course, when you buy a camera, it's always, oh, how many megapixel is it? You will find, and Eric stands me by, is that astrophotographers don't talk about how many pixels, but they tend to talk about the size of each pixel. And the size of the pixel, this also for Eric's interest of this camera, is a whopping 8.14 microns, which is large compared to modern ones. But it has an advantage, and the great advantage is that it works with telescopes of shorter, of smaller aperture very well, and I'll explain that later why that is. And more importantly, they are, of course, the bigger the individual pixel, the more light they can gather. And there is a better what they call signal to noise ratio, because there's a problem, and that is if you go and use these cameras for longer exposures, then the heat, they are sensitive to heat, they are sensitive to infrared radiation, and that would spoil the image. That's why they cool cameras. That's why they you know, proper, you know, expensive CCD cameras have a cooling element in them to reduce that problem. In video cameras, you don't tend to have that, or at least not in these that I have here, and they're not absolutely necessary, as you shall see later. What I also use is a website called Astronomy Tools, and they can punch in an awful lot of details about your telescope, about your CCD camera, etc., or your video camera, and then it will give you an awful lot of interesting information. I found out, for example, that I can produce 1.16 arc second per pixel visually with the same telescope, and that would be my 6-inch Newtonian. I should be able to get 0.77 at normal seeing. So, you know, the pixels are slightly too big to be optimum, but that's not so bad because, you know, even normal seeing is rare. And if I was increasing my my focal length, then you know, image is getting softer. So it's not a bad thing. Also, you can calculate other things like, for instance, that the ring nebula, if with this camera, with my Newton telescope plus Barlow lens, I can calculate that you know, that the ring nebula would be about 72 by 52 pixels in diameter, regardless how many megapixels there are in the camera. That doesn't change. That only depends on the size of the pixels. For video, frames per second is also important, and especially because one thing that these cameras do, and that is really why they are so interesting, is they have a thing called frame integration. And what that is that this camera, the Mintron that I use, produces 30 frames per second, which is pretty standard. But I can add the frames together. So I can say add each 2 frames together, or 4 or 8 or 16, all the way to 512 frames. I can add up before it sends it as a video signal. So basically what that means is that the stacking that you would normally do on the computer happens actually in the camera itself real time. And that means, okay, the number of frames per second reduce. In fact, actually, I end up with about 5 or one frame every 5 seconds. But I get an awful lot of information in that frame. Also, there's an awful lot of gain control on this camera, and that's why I can reach, you know, something like stars with 17.8 magnitude even on my refractor, and more on my reflector, on my Newtonian reflector. You also need some software. I tend to, you need some kind of sky chart software to find your way around the sky. I still use CartesiaL, which I love, and I am in the process of downloading the new Gaia DR2 star catalog. That gives you stars up to magnitude 18, ideal for my purpose, but that's 8 GB worth of catalog. I also use a free video capture software. You also need a video capture tool that can change composite video into USB. You pick them up for about a tenner from Amazon, or other brands of websites are available. I still use Registrax for stacking if I want to do some image optimization, because what you can do with a video recording is you can actually take all the individual frames of a video and just throw them into Registrax and then stack them all together. And I'll show you what the effect of that is. It's pretty impressive. I sometimes, not always, if I like the idea of it, use PaintShop Pro or something similar, just to do some minor image processing. For instance, removing some noise or a dead pixel if I forgot to put in a dark frame, as they call it. That is not free, of course, but there are free image. There's free image software as well. And then there's another bit of software I use, and that is Astrometica. It's free, but it's not essential. But that allows you, in fact, to calculate the positions, but also the magnitudes of the stars in your photograph, in your image, and it takes the information from the Gaia DR2 star catalog. So it compares your stars with that in the catalog, and I'll show you why that is necessary later. And then, well, necessary, but why I use that. Finally, you can have, if you want to, a YouTube channel with free video streaming software if you wanted to share your videos. Some observing tips then. Dark side. is always good, although video astronomy is somewhat forgiving. I've heard people I've seen examples of videos and images that were taken at nights when there was a full moon and all sorts of other light pollution. Still very, very good images. The method is seeing, of course, is sharper the images. I found wind a problem. Of course, even with the big beefy HEQ5 mount, you still get that it shakes when it is too windy. So I tend to not go out if the wind speeds are, beyond force 3, because then it becomes a pain, or I find somewhere a nice lee spot to do it. But moving images, especially when you are starting to stack the images together in the video camera itself, then it becomes all blurry and horrible. You need some kind of polar mounting and with some tracking if you use a telescope. You can, of course, use these cameras also with wide angle lenses on them. You can even get the original surveillance camera lens on it, and you can do all sorts of interesting stuff. Looked at the Milky Way and constellations and you name it. But the moment you stick it on a telescope, you need to track. But because the exposures are so short, up to maximum of 5 seconds, you actually don't need guide. As long as it tracks, guiding is not needed. I do find that it helps to be precise when you do some polar alignment. And on talking about tracking, I actually, on my on my EQ1, and I'll show you that, I'm using this thing, 25 quid. And it is a little analog battery-powered clock that just turns my RA. And I'll show you how good that works. There is a little adjustment on there. If you you just switch it on, you point the telescope, you switch it on, you wait a minute or so for the slack to pick up, and then you use the little adjustment to make sure that it doesn't drift too much, and it works. So no expensive driven mounts needed if you wanted to start with something, something basic like this. Works absolutely fine. Good thing to do is make sure you have the handbook of your camera. Learn how to use your camera at home. Another thing I want to show you, sorry, I'll stop the share, and I'll show you is this. And you say, what is that? Well, I don't know if somebody knows, but you can't see it, it is too bright, but this is a tiny little vial of tritium, and it glows, and it will glow for the next 15 years. And I use that as a little test star, because when you look at it head on, it's only 1 millimeter across. I stick that in a little bit of foam at the other side of the room, and then I point my camera at it with a normal lens. You could also, of course, stick it a bit further away and use your telescope. Problem is with using the telescope that that you need to go a long way away before you get a sharp image. It's about 8 quid for a little tritium vial like this, and you get them from fishing tackle shops, funnily enough, because they use them to lure fish in the dark. Apparently, I have no idea. So a little tritium vial, and you can get them in different colors. I've just ordered a white one, but if you use a cheap normal standard lens on your camera, then you can use that to do a bit of practice in the dark to start to focus it and get the right effect. And you can put the little virtual star a little bit further away. I know there are also a virtual star. You can buy virtual stars. They are horribly expensive. For 8 quid, you have one of these. You use a lead and a bit of cardboard with a tiny little hole in it, of course. They are a bit brighter, but I like the fact that it is faint, because then I can really try to make the camera work for its money. One of the things that you need to do, very important, is sync your finder scope with the screen. So what you do is find a nice bright star, stick it in the middle of the screen. It is a bit fiddly perhaps, but then adjust, once that is in the middle of the screen, adjust the finder scope so that it points also exactly at the star. That means that you can then easily use the finder scope to do some fine adjustments, because you will find that the field of view you get from these video cameras is not big, especially not if you use, for example, the a barlow lens, if I use a barlow lens on my Newtonian telescope, the field of view is getting very, very small, as you shall see in some of the samples. And sometimes even with Go2, it is not always perfectly pointing at it. Usually it is within the field, but not always. And then I can, of course, use the finder scope to find my way around. I also do the star. This sounds really odd, but with people with Go2 mounts, if I put my camera on the Go2 mount, I actually do the star, what you call it, the adjustment at the start, so that doing the 3 stars at the start to line up alignment stars. Yes, there it was. To do my alignment, I actually do on the screen of the computer, and it makes sense because I want the object to appear in the middle of the screen in my computer. I don't want it to appear in the middle of my eyepiece or my finder scope. It always takes time focusing. And the trick I use is what a lot of people do. You turn past the focus and then back again and forward, and you go past the focus a few times until you find the sweet spot. It is so much more important that you focus right, and it is so much more sensitive focusing using a video camera, because your eye, when you use an eyepiece, has still some adjustability in itself. Your eye itself can focus even on a slightly out of focus telescope. You can't with the video camera. It has to be spot on. Also focus on stars at a low frame integration, because the more, the longer it takes before you see the new image, the longer it takes to focus. So I tend to go to a reasonably bright star, go slow, a low frame integration, maybe only like at the most 16 frame integration. Which means that I get a new image every half a second. That's nice and fast. And I do my focusing till it is really razor sharp, clamp the focus, and then I can go and start my viewing. You do need to sometimes change your focus over a short while, especially when it is cold, when the tube of your telescope is stretching or shrinking. The tiniest bit can have an effect. Experiment a lot with different settings, take a lot of footage, and as always, the more you practice, I found, the better the images get. I thought I made good pictures at the start, but they got better and better the longer I did it. So let's show some examples. Now, this was in 2003 with my QuickTime Express, and on the left here is a little photo that I integrated using Registrax. This was on an old telescope I had, but I'll show you I'll start a video. So what you see on the right hand side is what you can actually see on the screen. So that's the little video that I could see on the screen on my laptop. And I cannot remember, it's about 20 seconds. And what I then did was I took that video image, and I took the individual frame, stuck it in Registrax, and I produced this image here. And it's not bad. I mean, we're talking, 17 years ago with a cheap monochrome web camera that I butchered with no cooling, no nothing, and that is and the seeing was average. Other people got far better effects themselves with this camera. But let's move now to my video cameras. So these are images that I made with my Mintron. So that is the smaller of the two, the monochrome. And as you can see the Ring Nebula here, you can clearly see the white dwarf in the middle there. You can even see that other star that sits a little bit to the side. And as I said earlier, it's about 72 pixels across. And you can say, well, that is, okay, doesn't look like much, but I find this very interesting. In fact, actually, it's not far from what you see when you see it live. This is a composite image. To the right here, this is just a single frame. No Registrax used, just taken a single frame of M27 while looking at the screen. This is what you see when you point it at M27. I was once with a friend up the road here, and there was a physics teacher, and we were putting up the scope, and I used this camera, and I did my star alignment, and I typed in M27, and that appeared right in the middle of the screen, and the physics teacher couldn't believe it. He said, why don't we have this? I said, I don't know. Now here are some other examples. So on the left, but this is my very first attempt of doing M1, and I can tell you M1 is difficult. Visually it's difficult, in the telescope, in the video camera too. It is very, very faint. And as you can see, you see all sorts of noise appear here, these lines. And that is because you really need to cool the camera to get the best effect. You can even see it even worse in the color video, in the Hooveron, in mono mode. As you can see, you get a far better image with the Hooveron. Very, very, very good camera in mono mode because you've got 4 times as many pixels. Very sharp, very beautiful, but you get this halo, and that is all the noise because this is a maximum frame integration. Because the pixels are smaller in this camera, because it is, you have got 4 pixels per pixel, if you wish, you know, red, green, and blue pixel, and an illumination pixel. The problem with that system is, of course, that it is less light sensitive. You need to integrate more pictures together, and you get a lot of noise. But still, I mean, I'm okay. This is an integrated image, and I did push the what you call it, contrast quite a bit, and you can see also some defect pixels here. You pick them up because they move, because of course the stars move, but I track them, and then therefore the dead pixels, they go like that. That's why I know that this is a composite image, because you get these dead pixels that move. They are not stars. A few more live images. This is M81 Bode's Galaxy, and this is M33. And as I say, I did a little bit of after image adjustment, but this is not far off how you would see it on the screen through a 6-inch Newton telescope with the Mintron. So very, very, and I see a lot of detail here. I really like these images because I get a lot of information from this in a tiny little thing that happens here. Some star cluster. I think that somebody will know, can tell me which star cluster that is. And then we go to the bit that I like most, and that is supernovae. So the first supernova I photographed using, or filmed using my video recording, was the one in 2011 FE in M101. There it is. That's the supernova. See if I can move it again. So there's the supernova. And I told you about the Astrometica software. I actually used that on this image to calculate the magnitude of that, and I sent this to Queen's University. I think it is Queen's University in Belfast, and they were mightily happy with the information. Might be someone else at the time. It was 9 years ago, so I cannot remember exactly. But I sent that information, and they were happy with the information I had. So you sent the timing and your magnitude, and that can help them calculate the curve. Now, in another one here, there it is. That star is a supernova that was also in 2011. In fact, actually, that supernova was before this one. It was not as bright. This one was, the one in M101 was almost so bright that you could see it with the naked eye, because I think that it reached something like magnitude 6 point something, so very close to visual range. And of course, in 2014, a couple of years later, we had a supernova in M82. Both these images are, now this image I think I made yeah, this one is made in the Mintron again, monochrome. Here you can see the supernova. I didn't put the circle, so clear. And this one I made in the color Hooveron. And again, you see the ghosting of the noise of the camera, unfortunately, because this was a reasonably high integration. But there is your supernova there. And in fact, somebody in Haas, I cannot remember who, brought a picture. I think it was Tony, who brought a picture that was made with a 20-inch telescope somewhere, but mine was better, just using a video camera. You can do comets as well. Here we've got Comet Garat 2009, or discovered in 2009. This is 2011 Pan stars. or C2011 L4. That was taken in April with the, so this with the Mintron, this one again with the Hoover-on color camera. I must admit that they are not as spectacular, but it is interesting. You can see here very clearly an ion tail, and especially if you do a little bit of image processing, you can get a lot of information out of this picture. And yes, it does globular star clusters as well, both taken with the Mintron again, the monochrome camera. And as you can see, you know, M13 is glorious. This is, I also took M92, much smaller, as you can see. And, you know, I needed to crank up the brightness quite a bit. I didn't increase the contrast because then you lose the center. It just becomes one big bright blob there. And then finally, these two images may not be that interesting because they don't look that great, but I just wanted to push. I wanted to push to see what I could see. On the left, this is NGC 3628, or better known as the Hamburger galaxy, and you can look it up later and you can see some structure. You can see the dust laying across it. That is very faint. That is challenging even with the best cameras. And then obviously you will never see, or I haven't in a normal telescope ever see the Horsehead Nebula, but the Mintron can pick up the Horsehead Nebula if you really, really push the boundaries of it. So maximum integration, maximum gain, a lot of contrast, and then you can see the Horsehead Nebula live on the screen, which is good fun. Now, I was also going to promise I was going to show you an occultation. So this is a recording I made back in 2010, I think, and it's the asteroid, yes, phenomena that is getting a star that's getting occulted, and it is this star, I'm sure, that will. And I think when the clock is 55, you will see the star disappear. So there we go. Bang, it's gone. Now you say, no, it's not disappeared, it's still there. Yeah, but that is because that, my friends, is the asteroid you now see. So the asteroid is covering the star, but the asteroid also has a magnitude, and it is bright enough to be picked up by the camera. And then there's also something moving here. I've never worked out what that was. You can see it move. Just moves in that path. I think it must be a telescope. Oh, we are back, as you can see. So there you go. That is an occultation video. And again, I encoded this time. Whilst it was not super precise, I did set the clock up. I set the clock in the computer. I corrected it to the time on a. Oh, I want to stop that now. On a satellite, or what do you call it? Yeah, satellite clock or a radio controlled clock. But again, they were still happy with that data. I said, look, you know, you probably need to add a second each side just to be on the safe side. So where would you start? Well, if you want to do it all very cheap, you know, you could do it the way I did. Just get one of those. They still make them. They're still great cameras, the V-Star Travel 102. On a cheap mount, buy yourself for 25 quid one of these. And then perhaps maybe one of these modern guide scope cameras, which actually, especially this ZWO, and Eric will tell you a little bit later about that. These ZWO cameras are amazing. They are exceptionally good value, £150. The Mintron at the time cost me about 300 quid. They're still 300 quid. So this one, you know, half the price and an exceptional image. So we'll want to one of those little tubes. They're about a tenner, and the reason for that is so that you can remove the star diagonal, replace it with this, so you look straight through. No mirror images, no loss at the mirror. And I think that you can make fantastic images with that. If you wanted to go one up, you know, I still think that the Star Travel is a good beginner scope for this kind of work, but you could get a slightly beefier go-to mount if you wanted to. If you went down that route, you're more looking at the 750 quid. But of course, most of you may already have a scope. If it is not driven, you know, find a way that you can make it, you know, driven. If it is already a go-to telescope, you're laughing. All you need is a camera. and you can start. My own wish list, as I say, I currently have a 6-inch f5 telescope. I've seen some fantastic results with 8-inch scopes. That little bit extra aperture could come in handy, means that you don't need this so much frame integration. I've always liked these quattros, so they're very, very fast, because the faster the scope, you know, the more light they grasp, the better it is for especially deep space imaging. I could go even as far as going for the 10-inch quattro. Nice and compact as well compared to other 10-inch scopes, but this is already, I find my HEQ mount could take this easily, no problem at all. But this, you know, something like this is also nice, because you've got a 1000mm focal length, and that helps, especially with smaller objects. And I'm eyeing up this camera. It's not as expensive as the one that Eric is going to talk about in a second that we have at Haas. In fact, actually, it is around the same price as the Mintron used to be, or still is. But this is a cool CCD camera. But and this is the interesting thing, it also does video. You can actually, I cannot remember if I read the spec correctly, but it can do a lot of frames per second. And Eric may keep me right here. It does onboard frame integration. So you can actually do some serious stuff with it. Also, the pixels are a lot smaller, so you can get sharper images. So, for example, M57 instead of 92 by what was it, 52 pixels. In my current scope, you know, it would more than double the number of pixels, so it would make it twice as sharp, the image of the Ring Nebula. So I may well invest in first the camera, perhaps see how it works of the current telescope, and maybe get a slightly bigger tube. But I must admit, these Skywatcher tubes are incredibly good for this kind of work. So this is an example of this telescope on that tube. So this sorry, I'm telling a lie. It is this camera for £300 on my current telescope would give me this kind of images of, in this case, of course, M42, or of what you saw earlier, M27, the Dumbbell Nebula. This is very encouraging. So I'm looking forward to do some of that experimentation. And that's about me. So I don't know if anybody has any questions, or Pete, if you want to take over again. Oh, Eric has been invited. Very good.
Yep, okay. That's what we thought we'd do. Bring Eric in.
Ah! Eric is in the space station toilet at the moment.
Yeah. So that was good. That was really good, Maarten. Absolutely fantastic.
Well, as I say, people always wondered, they said, why don't you get yourself a nice, cool camera? But I just love it to switch it on, you know, and it appears in the screen. You can actually see it move in the screen, you know, and it sits there, and it changes every few seconds, you know, if the object is bright enough, and you can record it and then worry about, you know, stacking it at a later stage. You just record it, enjoy it there. You can see it there on the screen. And it's really pretty amazing. So
there's no questions on there, but can I ask you, have you ever thought about taking dark frames and adding those to those deep sky images?
Absolutely, and I've started doing that at some point, and Registrax does that. So you just basically put the cap on, you know, or the cap on the telescope, and just basically put the hood on the telescope, and then I record for a minute or two.
Yeah.
And then I've got plenty of dark image. Yeah. And then I capture the noise and I subtract them, and that works very well.
Yeah. To say that's the one I'm still using, believe it or not, for me, planetary and lunar stuff, which is the Philips 2U cam.
Oh yeah.
You know, 2U cam Pro. But the good thing about this is just when they on add to it, you can take it. Could take it out. This one got stuck in that music for so long. You can actually put filters into there. I quite often use IR blocking filter, which makes a great.
Yes, I do. I did get myself an O3 filter.
Yeah, I got one of those.
That screws in front of my little adapter as well, into this little adapter, and then And that is very good for planetary nebula because I love, that would really bring out things like M27.
Say that camera there isn't really any good for deep sky stuff. It's more for planetary and lunar. It's really, really good for that. But apart from that, it's not going to do anything more. But it's a cheap, cheap way to get into video photography, video astrophotography.
Oh, absolutely. And I don't mind doing the odd bit of planetary stuff, but the deep space stuff is really my domain. I love that. Yeah.
Oh yeah, I'll use my Canon for that.
Yeah,
okay,
and see, yeah, I know. And I didn't want to go down that route. I tried with. I have got a mirrorless camera. I bought all the adapters for it, and I just cannot get anything. I don't get anything that I find remotely interesting. I find it far too fiddly. I cannot get it sharp. There's so many things that I don't like about it. I cannot have a live feed from it, so I cannot look on a big screen. Oh, that's not true. I've got a Wi-Fi live feed to my tablet computer. I've tried everything, and it is, and I can push it because it is something like 128,000 ISO. But I just, no.
It's just not for you.
It didn't work for me. I think I'm gonna go down the route of ZW, or what is the other one, HQY, CCD.
Yeah.
One of those really cheap, and don't get me wrong, they may be cheap, but it is like everything that comes from China. It is still very good. I mean, Eric can tell you about that. I mean, the stuff that he produces with this camera. Okay, that is not a cheap camera, but that's.
So you're going to show us that camera, will you, Eric?
Yeah, if I can share my screen, I think. So I put a couple of pictures on a PowerPoint thing, so
yeah,
I anticipated that this might happen. See if I can do this now.
I'll stop my video.
If anyone else has got any questions, mind, just put them in the Q&A and we'll ask Maarten or Eric or myself, whichever.
Yeah, I think it's worth saying that it sounds daunting at first, but what I found is, especially if you don't spend too much money, and the other funny thing is that I find that my camera, I could probably sell it still for about 200 quid. I would only have lost £100 in it in 20 years, or sorry, in 10 years. And these cameras do keep value. Eric has started.
Okay, I'm still learning this, guys, so just bear with me.
Oh, you still have the follow scope. That is good.
The what scope?
The wee follow scope on the back.
Oh yeah. That was a cheap. That was a scope out of Lidl's. Would you believe? My 7700mm scope. I use that as a guide scope. And I've got. I don't know how to point. Is there a way of pointing to certain things on this? Or,
I see it already. You're pointing. You're pointing.
All right. Oh, so
you can also start the presentation, and the image is bigger.
All right.
Yeah. From beginning, top left hand.
Yeah, I'm just wondering whether I'm on the share. Oh, hang on.
Yeah, you are sharing, Eric. We can see it.
There we go.
Is that it now? Okay.
That's full screen there.
Right,
yeah.
That's my kit. So hang on. That's what I was showing you.
Yeah.
And if I zoom in there, that's it.
Yeah.
Now I've actually got two ZWOs, if you can see. That's the lovely, expensive one, Maarten, that you were talking about.
Yes.
But that's my little planetary one, which I haven't actually used for imaging. I use that for guiding, and it's a damn good. It's a damn good.
Yeah, that's I think the one that I'm planning to buy. It's maybe guide scope, but it is cooled and it does fantastic deep space.
Oh yeah, the one you were talking about there is much better than this. Is a really elementary one. This is only a 2.9 micron pixel camera.
Oh, okay.
Good enough for Jupiter and things like that. But this one, right, this is the 071 MC Pro, and that's cooled. Pete, you asked if do you do dark frames? I did at the start, and then I realised I was never having to subtract anything because I can cool down to like minus 20, minus 25C, and you don't get any hot pixels or anything, so there's no point in doing that. However, you get cameras which are not as high spec as that, but they've still got the same chip and everything, and then the same software and firmware and everything, and they're just damn good cameras, You were talking about frame rate, Maarten, which is very important. and this camera ranges from 10 to 172 frames per second. So there's a hell of a range of stuff you can do.
Yes, that's what I mean. It's amazing, incredible.
Yeah.
Yeah, yeah.
And off-the-shelf software. Now, I use SharpCap. Everybody's got their favorite software I know they use. And the free version's pretty good. But you know what? See, if you pay your £10 a year, and that's all it costs, you get your license and it gives you the full capability of that software. And it's really remarkable for doing video or static, so to speak. And I absolutely take your point. You put in your introductory slide that it's lovely being at the scope and live observing. And that's effectively what you're doing. You know, I might integrate for 3-4 minutes, but to me that's live, you know?
Oh, yeah. Yeah, but some CCD, you know, some guys with their SLRs, they're just sitting there for half an hour, you know, or longer exposures, and you know, night after night, and then they have to integrate the whole lot.
Yeah, mine.
You know?
Last month I was there, sort of about 3-4 hours taking different images, you know, for 3 nights on the trot. So, but I did have the Dobsonian out at the same time, so I was viewing as well as taking images. So, you know, there's ways around it.
Now, there's something that I do as well, which is I can stick like a telephoto lens on 3D printed adapters and filter holders, things like that. So you know, you're marrying a couple of technologies together to get a compromise between expensive and cheap, you know, but still very effective.
Yeah, very wide field.
Very well. Well, you need that for Milky Way, well, comets and things like that. This is my setup. This is you talked about focal length, and that is absolutely critical with these things. Especially because I am wanting to make sort of beautiful pictures, aesthetic pictures as well. So you can see here, you know, I've got my focal reducer to try and get a wider field and a faster, faster image basically. Filter holder, and then spacers to try and get that focus bang on, because if you don't, you know, you end up with lopsided stars, and you know, it's a bit off-putting. These are filter holders and that I designed and printed, and they work very, very well, I have to say.
Okay.
These are things I use to get the focal length right. Sometimes I don't understand the maths of it. But you know what? When I see the stars pointing one way or another way, I know I've got to come in and out a bit.
Yeah.
You know? That focus, Martin, you were going on about focus, absolutely, again, critical. I tend to use a batten off mask. And if anybody's ever used one of these, that's what you're looking for. And once I get that, I know I'm ready to go. And then I start imaging. It's my guide scope stuff. That is what I see live on the screen.
Yes, amazing. Yes.
And it's wonderful. And that's, you know, when I see that, of course, I go, well, if I can get 20 or 30 of these and stack them, I'm going to get a good image out of this. But I think that's remarkable. That's just one stage more, slightly one more stage than your video cams, Martin. But look at that. I mean, that's, you know, so I'm doing live observing and capturing data for my astrophotography using a video cam, a webcam, whatever. Yeah.
Then Eric, how critical is a guide scope?
Absolutely. Well, I'm trying to see if I've got. There's one right there. So there's a 4-minute exposure of the whirlpool. So I absolutely have to guide because you know, you've got periodic error, all kinds of things in here. Even I've got a it's a CQX mount for in my observatory, but I also have the HQ5, the more modern version of it, and they're good. But even if you're
you need to guide. Yeah,
2 minutes.
Well, I mean, if you pay, I don't know what you paid for that camera. What is it, $2.5 or so, or $3?
No. That was. It would have been. It's still expensive. It would have been about 1,400, but
right.
It was a shop demo model, so they gave me 300 off it. And so you know, okay, that's not cheap. I know it's not cheap.
No, but if you are, you know, going to that stage in your hobby, you've done this for 20 years, Eric, then buying a guide camera for 150, 200 pound, you know, is of course not a wasted expense.
No.
And the nice thing is, it's one cable. You plug it straight into the HDQ5.
Yeah. Well, the thing, yeah, no, that's exactly what you do with the guide thing. But the one thing, these cameras as well, they work. You need USB 3 to work effectively, because there is so much data packets. You know, like you mentioned as well, the buffer things, they actually sort of semi-stack them before it gets sent to the actual computer. So you need to have USB 3.
So Sam's actually asked me a question here, which is he's saying he's actually got a 2U cam as well, used on the moon and planets. Would I recommend high frame rate to beat seeing prior to processing in Registacks? I always try to use the highest frame rate possible that allows you to get a decent image. It all depends on your scope, I think, and your seeing and everything like that to what you can use. But I would try and get the highest frame rate, that I can. I think. Would you agree with that?
It's like Maarten said. I think there's a lot of it's trial and error.
Yeah.
You can read books and have theory about it, but see when you actually start dialing in the buttons, increasing gain, reducing gain, all that stuff, you will find fairly quickly what is working on the night.
Yeah.
Because
it varies per night. I mean, this is an important thing. It varies per night. It also, one of the things is that sometimes I pack in my one scope and I get another one out.
Yeah.
Because I find, for instance, that the bloody aperture is too big for the seeing that you get for that evening,
Yeah.
Because that is another thing that a lot of people don't know. But everybody talks about, I need to get the 16-inch scope and things like that. Well, in Scotland, a bit of waste of money. The times that you get seeing that gives a, undistorted frame, even for a second in a 16-inch scope is minimal.
Yeah.
I think that the 12-inch scope that we have in Culloden is about the maximum that you would ever want to.
Yeah.
It's great for a lot of light, but for astrophotography, it's a bit of pain because you don't need all that much aperture. More is better, but up to a point with the seeing.
I think it was you and Anthony explained to me about the cells.
Yes.
Quite often in this country, of our latitude, the cells are such that you end up with just so much distortion that you are actually better with a 4 or 6-inch scope. Quite some night.
Yeah, indeed. Yeah.
There's your favourite, Maarten.
Yeah, absolutely. It's incredible. Yeah, incredible.
And that's just live off the screen as well.
Yeah, superb.
Yeah, and that's my little big checklist. When I'm doing my stuff, that because I'm doing, I'm wanting to process my images to get, not Hubble quality, but good quality. These are the type of things you absolutely have to check.
Yeah, and number 2 is to get to have no backlash at all.
Yeah, reduce it to the absolute minimum. A lot of folk try and get it exactly balanced, and it's just not good. You end up, depending on what altitude you're imaging at, it can go all floppy on you, basically. And even the guide scope doesn't control it very well. No. But that's just all learned by experience, So I don't want to steal your thunder, but
no, but that is lovely. I mean, the point was to do a little bit more beginning stuff. The kind of stuff that I do is possibly a bit more accessible for anyone that wants to set out. But I just wanted to I asked you to show this because it's just wonderful to see how how you can progress from this and how you can eventually go step up the quality of your video camera endlessly. But you can start.
I have to blame you for costing me so much money. It got me into this, and I did use the little webcam, that tiny little one, and I did a modification to the electronics at the back. I got that off the internet, and I did my first deep sky stuff with that, and it was actually successful.
Yeah, it was. Yeah.
And then it was a mixture of trying to do some cheap and other times going, what? Sometimes you are better throwing money. It's a balance. It's not one way or another like most things.
No. And then of course you got your fast star connection up with your scope, which is great.
That thing there is, I've got my DSLR connected to it, but I also have an optical train, with filters in it with my ZWO. And that thing, that's about an f1.9 speed. You can take fantastic, sensitive pictures in what, a minute and a half, 2 minutes. It's wide field. That one, my background there. See that background?
Hmm.
That's the Hart Nebula. That was off with the Hyperstar, and it had the hydrogen beta and O3 narrowband filter. That was what that was.
Hmm.
Superb.
Wonderful.
That's really good to be able to see both ends of the spectrum. You know what I mean?
Yeah, yeah.
See the entry level and then your level, Eric. You know, because I mean, let's say you are throwing money at that. That's definitely.
Oh, with that one there is money there. The great thing with the observatory as well, of course, is Maarten mentioned the wind, and I've done outdoor setup stuff, and it's great. But the minute you get a bit of wind with these very, very sensitive cameras, you've had it.
Yeah.
But the observatory, of course, you're shaded, and you can do it. Plus, you just go outside, push the button, within 5 minutes you're going. So
it does make all the difference.
it
I'll agree with that.
you know that well, yeah.
Yep. Okay.
Quite a bit of 3D printed stuff in there, though, Eric, as well, which is
Well, that's actually helped. That really has helped me because the focal length thing. You get adapters, they sell them, but you're always 2 or 3 millimeters out. And to buy the ones that you need, you can be 40, 60 pounds for a little ring of metal with a couple of threads on it, and it's ridiculous.
Mm-hmm.
Whereas although I'm a biochemist, I've managed to become a good enough design engineer to design some of these things that you need for us. So.
yeah, but it's all just down to fillets, mate, isn't it?